So you'll see that the two formulas for converting between radians to degrees, if you're changing degrees to radians, you're going to multiply by pi over 180. If you're going from radians to degrees, you're going to multiply by 180 over pi. Before we do that, though, let's take a look at these two graphics down below, these two circles, and the way the angles are split up. So we already talked about that 360 is 2 pi. And let me do it in a different color so we can see this a little bit better. And that 180 is pi. So then if we cut that in half, we cut 180 in half, we get pi over 2 for 90. And you can kind of count by pi over 2's now. So if I go pi over 2 there, 2 pi over 2 for 180, that gives me 3 pi over 2 for 270. And now I want to cut that in half again to get my 45-degree option. So if I take pi over 2 and cut that in half, I will get pi over 4. So now I'm going to count by pi over 4 to get my other one. So I start with pi over 4 at 45 degrees. 90 would really be 2 pi over 4, which reduces or simplifies. Then I get 3 pi over 4 for 135. 4 pi over 4, which simplifies into pi for 180. 225 would be 5 pi over 4. 6 pi over 4 for 270 reduces to 3 pi over 2. And then 7 pi over 4 would be 315. So I don't actually need to use the conversion formulas from above. To get these, I can use a dividing up technique. And these are going to be radian measures and degree measures that will be very important for your future trig lessons. And I can do the same thing with the 30 and the 60 degree ones. So if I'm thinking at 90, I have pi over 2 for my radians. I now want to divide that up into thirds, and then I'll count that out. So if I divide that by 3, I'm going to get pi over 6 for 30 degrees, and I'll count by the pi over 6. So I go 2 pi over 6 for 60. That will simplify to pi over 3. Then 3 pi over 6 for 90 degrees, which simplifies. 4 pi over 6 here. Again, that simplifies to 2 pi over 3. 5 pi over 6, which does not simplify. 6 pi over 6 here, and that simplifies to just pi, so I'll just get rid of the 6. I was trying to keep the pi there, but that did not work. 7 pi over 6 will be my next one at 210. 8 pi over 6, which simplifies into 4 pi over 3. I'll just leave those up for a second so you can kind of see that counting aspect. 9 pi over 6, again, really simplifies into the 3 pi over 2 that we already had there. 10 pi over 6 simplifies to 5 pi over 3. And after 10 pi over 6, we will have 11 pi over 6 for our last important angle. These are the circles you want to really familiarize yourself with, and the angles. These are going to be important ones, again, that will carry you throughout your trig process later on. I'm actually just going to try to grab this here, if I can move that. It's not letting me. Okay, good enough. All right, now we're going to take and use our conversion formulas to convert these different values over. So if I want to convert degrees, I'm going to multiply by pi over 180. This would be a good time to use the fraction tool or put it back into fraction form. So I'm going to do 54 divided by 180. I'll keep pi in my answer. I get a decimal, so I'm going to put that back in fraction form. So that would give me 3 pi over 10. It's important to put the pi with the numerator. When we write these, it's just kind of the standard format. You could put it off to the side, but you don't want to get confused and think that it's in the denominator. Again, multiply this by pi over 180. Your alternative is to use the fraction tool. If you have access to one, to give you, in this case, negative 31 pi over 18. The key with these is to not multiply in the pi so you can keep your answers exact when possible. Going the other direction, we're starting with radian measures here. If you don't have a degree symbol, you're going to assume it's a radian measure. We're going to do the opposite and multiply this by 180 over pi. So the degree measure is now on top when we're converting to degrees. What you'll notice with these is the pi will cancel. If it doesn't cancel, you will have to multiply it in. So here I'll do 16 times 180 divided by 15. Most of the time these come out to be whole number answers, so you don't really need the fraction tool, although you definitely could use it. And make sure to put degrees with your final answer to represent this as a degree measure. And the next two are kind of similar. One of them is one of our special ones from the previous circles. I'll just do both of them at once and then we can write the answers in. So I hit enter by accident first there. So we get negative 72 for that one. And then 2 times 180 divided by 3. Both of these had pi in the answer, so that would have canceled out. This is negative 72 degrees and 120 degrees. If you look back even to the beginning of the notes here, this was the same answer that we got from number 3 when we were working on arc length earlier. So when we had the 2 pi over 3 and the 120 degrees, they matched up when we were looking for arc length. So that just also kind of confirms that the radian measure is your arc length. Now this last one, when we multiply by 180 over pi, unlike the previous ones where the pi cancels out, the pi does not cancel out here. So when you're typing this in the calculator, you do want to divide by pi and round your answer. It does not specify what to round to here, so let's just do 2 decimal places. And you actually want to use your pi button also. So second, the little caret button will give you pi, 100.27 degrees. All right, and in our last section, we're going to try drawing radian measures without converting back to degrees, just to get used to the idea of the radian measure as a fraction and dividing up our space. So instead of using 0, 90, 180, 270, we're going to use pi over 2 for 90, pi for 180, and 3 pi over 2 here. It's good to get used to these values and familiarize yourself with them. Do the same thing with this one. And working with radians is just a good practice in working with fractions. So the best thing to do is label your quadrantal angles and get a common denominator. So for this one, our common denominator is going to be 4. So we're going to change all of these to fractions over 4. So 2 pi over 4, 4 pi over 4, and 6 pi over 4. And that's actually as far as I need to go because I can see where the 5 pi over 4 is going to fall into. It's going to fall right in between the 4 pi over 4 and the 6 pi over 4. And then we'll just draw our arc and label that as 5 pi over 4. So a common thing that people do when they first start learning radians is they try to convert things back to degrees and then answer the question in degrees and put it back in radians later. That takes you a lot of extra time that you don't realize. Although it will be a slow process to learn the radians initially, it will make future things a little bit quicker if you can understand where these are going. Right, this one's a little trickier because to get a common denominator here with 3 and 2, we need to make both of these common. So we're going to 14 pi over 6 for this, and then we'll make all of these over 6. So 3 pi over 6, 6 pi over 6, 9 pi over 6, 12 pi over 6. Now what you'll notice, 14 pi over 6 is more than the 12 pi over 6. So this is one of those angles that's more than one rotation. If it were in degrees, it would be larger than the 360 degrees. In this case, it's larger than the 2 pi. If I were to keep this going and add another 3 pi over 6 onto here, that would give me 15 pi over 6. So I can tell that the 14 pi over 6 will fall into the first quadrant. It'll be fairly close to this. But because it's more than one rotation, remember to go around one full time and then up again to the top. I did not do an example with negative, but the negative would work the same way, just like we did with the degrees. You would label it going the other direction. So you'd put negative pi over 2 on the bottom and then go around the other way. So that is it for converting radians to degrees and seeing them visually and drawing your angles. So you will now have a chance to complete the practice. I definitely recommend if you have questions before you start the practice to make sure that you ask them.